Today we are going to discuss sample distribution of size 2 without replacement problem. Okay, so now we are going to discuss a problem of size 2 without replacement. What he has given is the numbers 2, 3, 6, 8, 11. 5 numbers he has given. We have to form a sampling distribution of size 2 without replacement. Okay, how it will be, let us see. So first I am writing the two combinations. So 2, 3, next you come across with the 2, 6, next you come across with the 2, 8 and 2, 11. So 2, 6, 2, 8 and 2, 11. Next three combinations, 3, 6, 3, 8, 3, 11. Just to go through forward direction only. So you come across the 3, 6, 3, 8, 3, 11. Okay, next 6 combination. How will you write the 6 combinations? 6, 8 and 6, 11 only. 6, 8, 6, 11. Next you come across with the 8, 11. So how many odd pairs you come across with? 10 pairs available. So you can predict how many pairs you are going to get in the sampling distribution. How it means, here the how many numbers are there? 5 numbers are there, size 2. Therefore 5C2 number of pairs will be there in the sampling distribution. 5C2 is nothing but 10. So how to find out the mean of the sampling distribution? How to find out the mean of this sampling distribution? For the first ordered pair, what is the average? 2 plus 3 by 2, that is nothing but 2.5. For the second one is 4. So 2.5 is the average of the first ordered pair, 4 is the second ordered pair average, 5 is the third ordered pair average, 6.5 is the fourth ordered pair average. Similarly, for the second row, these are the averages. For the third row, these are the averages. For the last one, 11 plus 8 or 8 plus 11, 19 by 2, 9.5 is the average. So next what you have to do, you have to find out the sampling distribution. Mean of the sampling distribution of means. This is the sampling distribution. This is the mean of sampling distribution. Now we are going to find out the mean of the sampling distribution of means. Okay, so how we have to do, you have to add these values, 2.5 plus 4 plus 5 plus 6.5, so on up to 9.5 divided by 10. So you are going to get 6 as the mean of the sampling distribution of means. Similarly, you have to find out the standard deviation of sampling distribution of means. How will you find out? The formula is sigma x minus x bar whole square by n. That means x bar mean is nothing but 6. 2.5 minus 6 whole square. Next 4 minus 6 whole square. 5 minus 6 whole square. 6.5 minus 6 whole square. So on. 9.5 minus 6 whole square by 10. If you do that one, you are going to get it as 4.05. This is nothing but the variance. How will you find out the standard deviation? Root of this variance. That is nothing but 2.01 is the standard deviation. So these two formulas plays very important role in finding the mean and variance. Okay, thank you. Today we are going to discuss sampling distribution of size 3 without replacement problem. Okay, so he has given the numbers 3, 6, 9, 15, 27. Size 3 we have to form. So first we have to form a sampling distribution of size 3 without replacement. Size 3 means each pair has the 3 numbers. That means 3, 6, 9. That means 3, 6 combinations I am writing. The next 3, 6 combination is what? 3, 6, 15. Next 3, 6 combination is what? 3, 6, 27. So 3, 6, 15. Next 3, 6, 27. Next what you are going to get after 3, 6 you are going to frame 3, 9 combinations. 3, 9, 15. 3, 9, 27. So after 3 9, which combination we are going to form? 3 15 27. 3 15 27. So therefore 3 combinations, 3 6 3 9 3 15, entire one is over. Next you have to come across with the 6 combinations, 6 9 15, similarly 6 9 27, and 6 15 27, and 9 15 27. So total how many pairs are there? 1 3 5 6 9 10. Okay, so now for this one we have to find out the sampling distribution means. You have to find out for each ordered pair you are going to find out the average or mean. For the first ordered pair, that is nothing but 3 6 9, that means 9 6 15 3 18 by 3 6. For the next one, 15 plus 6 21 plus 3 24 by 3 8. For each pair you are going to find out the average. So if you do like this, you are going to get like this, the averages. Now the first question, mean of the sampling distribution of means. This is the sampling distribution, these are the distribution means. Next we are going to find out the mean of the sampling distribution of means. That means we have to add the entire values divided with the number of values is 10. So 6 plus 8 plus 12 plus so on 17 by 10, that is nothing but 12. Similarly we have to find out the variance of the sampling distribution. That means 6 minus 12 whole square, 8 minus 12 whole square, similarly 12 minus 12 whole square, so on 17 minus 12 whole square by 10. If you do the calculation, you are going to get it as the 13.3 as the variance. Therefore standard deviation is root of 13.3, that is nothing but 3.651. So the mean of the sampling distribution is 12 we are going to get, and the standard deviation of the sampling distribution is 3.651. Okay, thank you. Today we are going to discuss sampling distribution problem. So a random sample of size 100 is taken from an infinite population having the mean as 76 and the variance as 256. What is the probability that mean will lie between 75 and 78? That is the problem he is asking. So let us discuss what the data he has given. Okay, first the size of the sample he has given is n is equal to 100. Okay, that I am writing here. Next one, mean of the population 76 he has given. Okay, next one, variance of the population 256 he has given. Similarly, from this one you can conclude a standard deviation as 16. What is the question he is asking? Probability that mean x bar will lie between 75 and 78. That's why I have written 75 and 78. This we have to find out. How we are going to find out? Let us check. X is equal to 75. You convert into the Z scale. Okay. So the Z scale formula here is x minus mu by sigma by root 10. Okay. So if you do this one, x here it is 75 minus mu 76, sigma value is 16 and value 100. If you do that one, you are going to get it as the minus 0.0625. Similarly for 78, here 78 we are going to convert into the Z scale. If you are doing like this one, you are going to get as 1.25. Now in place of 75 you can write minus 0.625. In place of x you write z. In place of 78 you write 1.25. So what happens? Probability of minus 0.625 less than or equal to z bar less than or equal to 1.25. Now I am defining these values in a z scale. Minus 0.625 lies left to the z is equal to 0. and 1.25 to the right of z is equal to 0. So what is this area? Resembles this entire area between minus 0.625 and 1.25. okay, that is nothing but area of z is equal to 0 to z is equal to 6.25. from this line to this line I am writing here this notation. Next, from this line to this line I am writing in this notation. okay, if you get those values are 0.2334 and 0.3944. if you add this one, you are going to get it as the 0.628. so therefore probability of 75 less than or equal to x less than or x bar less than or equal to 78 is 0.628. okay, thank you. Today we are going to discuss sampling distribution problem. So here he has given a normal population has a mean 0.1 and standard deviation is 2.1. Find the probability that a mean of sample size 900 will be negative. So the given data is what we look at first. Mean he has given is 0.1. Second one, standard deviation is 2.1 and sample size n is equal to 900 he has given. okay, what he is asking, the probability of that a mean of so and so will be negative. Find the probability that a mean will be negative he is asking. That means mean probability of x bar less than 0 is how much? Mean is negative, that value you have to find out. Probability of that value you have to find out. okay, for this one we will use this formula z is equal to x bar minus mu by sigma by root n. okay, x bar value we don't know, but mu 0.1, standard deviation is 2.1, n value 100. if you simplify this one, you are going to get it as x bar minus 0.1 by 0.07. okay, that is nothing but if you do the cross multiplication, 0.07 times of z is equal to x bar minus 0.1. that means we need x bar is equal to 0.07 times of z plus 0.1. so probability of x bar less than 0, both sides you apply the probability of x bar is nothing but probability of this one. so probability of x bar less than 0, left hand side, right hand side also you apply less than 0. therefore probability of 0.07 times of z less than this plus 0.1, move to the right hand side, you are going to get as minus 0.1. now here divide with 0.07, you are going to get as the z less than minus 0.1 by 0.7. that is nothing but probability of z less than minus 1.43. that means now you take a diagram, z is equal to 0 here, minus 1.43 left side of that one. so this one z less than minus 1.43 means this is the shaded area you have to find out. so how will you find out this shaded area? means from z is equal to 0 to this entire area is how much? 0.5. 0.5 minus this area gives this represented area. so 0.5 minus area of 1.43, subtract that one. that means 0.5 minus 0.4236, you are going to get as 0.0764. this is the value. okay, thank you. Today we are going to discuss sampling distribution problem. okay, assuming that standard deviation is equal to 20, how large a sample be taken to assert with probability 0.95 that the sample mean will not differ from the true mean by more than 3 points? that means error he has given, that is equal to 3. next one, sigma he has given is 20. next one here 1 minus alpha he has given as 0.95. From this one you conclude the alpha value, that is 0.05. Here we need the alpha by 2. How? Later we will discuss. Alpha by 2 is 0.025. Again 1 minus alpha by 2 is 1 minus 0.025, that is 0.9750. Okay, that means Z alpha by 2 value is, for this value you come across is 1.96. okay, so Z alpha by 2 is 1.96 value and n value is equal to question mark. Now again you go for the problem. Maximum error he has given is the 3 points that I have written. Standard deviation is 20. Z alpha by 2 is equal to 1.96. N value is equal to how much? How large a random sample be taken? That means n value is equal to question mark. The formula to find out n is Z alpha by 2 into sigma by E whole square. That's why we did the Z alpha by 2. This is the way to find out the Z alpha by 2 value. Therefore substitute all the values. Z alpha by 2 is 1.96, sigma is 20 and E is 3. Therefore if you do this one, you are going to get n value approximately equal to 171. okay, thank you. Today we are going to discuss sampling distribution problem. So the problem what he has given is a random sample of size 100 has a standard deviation 5. What can you say about the maximum error with 95% confidence? Maximum error, okay, sigma standard deviation 5 he has given and n sample size 100 he has given. Z alpha by 2 E value is 1.96 for 95% confidence. So the E formula you have to use, that is equal to E value you have to find out. E is equal to nothing but Z alpha by 2 into sigma by root n. Just Z alpha by 2 is 1.96, standard deviation is 5, n value is equal to 100. If you substitute, you are going to get it as the 0.98. So therefore maximum error is 0.98. okay, thank you. Today we are going to discuss sampling distribution problem. So the mean and standard deviation of a population are, he has given. What can one assert that 95% confidence he has given, and we have to find out the confidence interval. okay, so what he has given is mu 11,795 has given, standard deviation 14,054 respect he has given, n value sample size 50 has given. You have to find out E. Maximum error is nothing but formula Z alpha by 2 into sigma by root n. okay, so E is equal to nothing but Z alpha by 2 for 95%. For 95% Z alpha by 2 is 1.96, standard deviation is 14,054, sample size is 50. Therefore error you are going to get it as 3899. Therefore confidence interval is the formula x bar minus Z alpha by 2 into sigma by root n, x bar plus Z alpha by 2 into sigma by root n, or in other way x bar minus error, x bar plus error. Therefore 11,795 x bar value minus 3899, 11,795 plus 3899. So that is nothing but confidence interval is 7896, 15,694. okay, thank you. Today we are going to discuss sampling distribution problem. So problem what he has given is the 10 bearings. Here the sample size is 10, that you have to always remember. okay, so sample size is 10, this is less than 30, always you have to use the T distribution. So here E is equal to T alpha by 2 into sigma by root n formula. Therefore T alpha by 2 value, okay, T alpha by 2 value for 10 minus 1 degree of freedom is 2.262. This is the formula. For if n is equal to 10, T alpha by 2 value, how will you get to for n minus 1, that is nothing but 10 minus 1 degree of freedom. If you look at that one, that is 2.262. Therefore t value alpha beta is 2.262 and the standard deviation is 0.04 he has given. N value is 10, therefore error is 0.00286. Confidence interval is x bar minus error, x bar plus error. If you do this one, you are going to get it as the x bar value is 0.5060 minus error, 0.5060 plus error. Therefore you are going to get it as the 0.5031 comma 0.5089. Here why you have applied the t distribution means n value is equal to 10 less than 30, that's why we are using the t distribution. Okay, thank you.